Health Data and FHIR at Microsoft. So previously introduced, again, I'm Dana Kaw in Health and Life Sciences Cloud and Data. I'm a senior program manager. I'll be presenting the initial part of this training module. The second half of this module will be presented by my colleague, who's a principal software engineer, Todd Morris, incredible depth of experience in the health space at Microsoft and well beyond. So we're grateful to have him co-presenting this module today. As we look at where we are in our learning track, this is our first module before diving into medical imaging, DICOM, many other modules ahead in the course, but just want to orient you in the linear journey of your learnings. What do we want to cover today? We want to look at interoperability a bit broadly, and then look at Microsoft's role and history in working with health data in the cloud. We're going to spend some time on the FHIR data model for those of you who are not familiar with the FHIR spec and structure and how that came to be adopted, particularly in the US, and is continuing to be adopted around the world. We'll look at FHIR's motions with RESTful APIs, and we'll pivot to Todd to talk about architectures for API for FHIR, how we've designed our system here at Microsoft, and a specific use case as we talk about the Microsoft Cloud for Healthcare. As we move into the next hack over the coming days, this particular hack is not designed to get data specifically into the cloud for health, but does have many, many other use cases. So we ask you to really dive into this module and watch for the details of how you would use our tooling to connect data to the cloud for healthcare, because that will not be part of our hands-on experiences for this hack. Though, again, as mentioned previously, we do have other resources available to you at Microsoft to help you get hands-on keyboard as you look to ingest data for cloud for healthcare use cases. As you walk out of this module, we'd love to have you feel comfortable with how FHIR operates in a REST data mode, how data is ingested into the API for FHIR, and certainly how data egress out of our tools work. What is proxy OSS and some other capabilities that we've built to wrap around the API for FHIR and enable fine-grained access and other fine-grained controls, and how to specifically solution for a Microsoft Cloud for Healthcare use case. Interoperability, Microsoft, and FHIR. Before we dive into the spec itself, taking a look at why FHIR came to prominence over the last few years, we think is an important pause and starting point. So if we look at the way health organizations manage data today, we see that data is very often siloed. Data sits within individual departments. Data sits in repositories locally and not migrated to the cloud. The data is rarely uniform. Data sitting in silos across organizations requires a high friction barrier to often normalize and manual workloads that don't involve a standard spec like FHIR. And that work can be taxing and slow innovation in using that data for AI, ML, and other analytics workloads. Additionally, de-identification and non-uniformity of data is difficult and time-consuming. So to de-identify data without the enablement of a spec like FHIR is also a constraint, as is the constraint of geography, right? The semantics of health data, the normalization across geographies, prevents research at scale in areas like population health. The FHIR spec was developed, which we'll go more in detail into momentarily, by HL7 organization and the community of open source implementers who contributed to building out the spec to enable the ultimate goal of health data, which is making data interoperable. FHIR enables interoperability by enabling a centralized repository. Particularly our product, API for FHIR, enables organizations to store and organize their data in one place, converting legacy health data formats or formats that are used today into one common standard, which then creates uniformity. We mentioned as we looked at the wheel of our Microsoft Cloud for Health and where we sit in that we enable secure de-identification, and we do that at scale so that insights can be used for research, can be used operationally, and that Babelfish really allows you across your organizations or the organizations that you're supporting, should you be an SI, to take health data in highly readable formats and make use of that data for upstream applications and use cases. When we look at the history of Microsoft's role in health data interoperability, we came into the space really in 2019 by launching the medical imaging server for DICOM and OSS, and we launched our GA'd service of Azure API for FHIR. Microsoft in 2020 announced the Cloud for Health, which the API for FHIR is a part of, and the central vehicle to ingest, transform, and connect data up to Dataverse, Dynamics, and the other capability suites that are part of the Cloud for Health. And continuing on our innovation journey, we launched Azure Healthcare APIs last August. While I can't announce the date today, know that around the corner is spring, though it doesn't often feel like that in February, but around the corner is spring. And in spring, we will be announcing moving Azure Healthcare APIs to a GA service with lots of exciting feature functionalities around that. So really pleased to make that movement. We store today tens of terabytes in the API for FHIR, and we are doing over 7 billion API calls per month and growing rapidly. I think these numbers will look profoundly different even over the coming months. So know that this is a service that really, if you look at this calendar in the context and history of health data systems, context and history of Microsoft, is still nascent, but we are very quickly building GA'd highly supported services to enable our partners. I want to move to what the differences are between the two capabilities that I've spoken about through today's training, and that's Azure Healthcare APIs and the Azure API for FHIR, which is in GA. Moving forward from here, we're going to specifically focus on the API for FHIR because the API for FHIR is a GA service. As all of you move to putting hands on keyboards tomorrow in our hack, we want you focused on being able to use the tooling that supports production workloads with PHI in the cloud, connecting from the EHR directly to the API for FHIR, IoT devices to our IoT connector, and open source capability up to API for FHIR. As we move Azure Healthcare APIs to becoming a GA service, our GA capability under our BA agreement will support health PHI in that environment, as opposed to what we do not support PHI in public preview. And we'll be really excited to bring some new capabilities into the technology, such as workspaces for security and authorization, access management. We're going to be bringing capabilities like the IoT connector directly into Azure Healthcare API's product suite so that you can much more seamlessly ingest various different health data types into our core service and then store that data and then connect that data certainly out more broadly across the stack. So from here, I'm going to pivot to talking more about FHIR, its journey, and what FHIR specifically is. So FHIR is a next-gen set of standards and frameworks that are specifically designed to enable interoperability. FHIR is built on 4 central tenets. Number one, it's a set of standardized data models. Those models help normalize data. These models are often canonical or normalized, meaning no matter where you go in the world, a patient is a patient is a patient. There's a specific data structure to patient, which we'll explore in the coming pages. There's an API specification for exchanging those data models, and that specification is recognized in the same way that you would think of UL being a standards body for power. The movement of power through an outlet has a spec. The movement of data across the World Wide Web has a spec that's defined by HTTP protocols. So there's a very specific API spec for exchanging FHIR data. And there's a set of tools for building and interacting with those APIs. Many of these tools are available on HL7's website in the FHIR community, and that community is really a global community of implementers who are mapping these standards and bringing these standards to life. These standards are all about access control, They're about regulation. We're going to specifically call out the US, as the US government was one of the first to move forward with major legislation mandating the use of the FHIR spec. We appreciate that this is not a US-centric training, and as more jurisdictions move to adopt FHIR from both a voluntary and a regulatory perspective, we'll certainly update these materials and talk about those specific jurisdictions as well. Though mention that the US is a mandate, many other nations, particularly those with centralized population pop health management initiatives and central government health managed systems, are moving to adopt FHIR today. Couple principles in FHIR. FHIR is based in web standards. It's meant to be human readable so that you could look at whether it's an XML file or a JSON file, you could read in human text data within the health file and understand that data. It's structured to be able to be easily adopted through a pretty simple set of tools and resources, which again, we'll show you some samples of are available on HL7's website. So at the highest level, many folks in the health community really focus on the fact that it's the implementers who are bringing this spec to life, because if the spec couldn't be adopted easily, it wouldn't have traction and it wouldn't move to driving health outcomes. And I see Kim has a hand raised. Kim, can I take your question?
Actually, another one of our guests did, and I wanted to interrupt you for a question, so I'm just giving him an entrance. Pan, do you want to proceed?
Hello. Hey, yes. Hey, thank you, Dana. In your previous slide, you talked about the API for the health API that is in public preview. What is the difference like between FHIR and Azure API for FHIR and the other API that you talked about?
Sure. Let me go back to that slide. Okay,
Yeah.
so the fundamental difference today is that the Azure API for FHIR is a generally available service and has been for some time. Azure Healthcare APIs is currently in public preview, meaning we do not support putting PHI production workloads in that environment. That service can still be used today, but it's not used for production health workloads. We are moving to support production health workloads with PHI in the cloud, in the service, once that service is generally available, and that date is around the corner. So in the coming days, weeks, do be listening for an announcement from us on moving to Azure Healthcare APIs as a GA service with capabilities to, again, support IoT connectivity, not through open source tools, but native to the product. The medical imaging server for DICOM will also be supported natively within the product and not require using open source capabilities to connect imaging data, IoT data, or other data types into the Azure API for FHIR service as a GA tool.
Okay, so in that case, Azure API for FHIR will still be there, and this is a service on top of Azure API for FHIR. Is that the right?
They are two different, correct. They are two different services. We will be announcing with the release of Azure Healthcare APIs in GA, more direction on the plan for API for FHIR ahead. There are certainly use cases where you may want to use one service versus the other, and we'll put out some documentation around that with the of the GA.
Okay, thank you.
You're welcome. Okay. Thank you for that question. Appreciate it. So we're going to dive back into FHIR and look at its most fundamental structure, which is a resource. So you can think of a resource as a discrete data concept. Patient will be the primary example we use through this course today. A patient is a normalized resource within the HL7 FHIR organization, meaning that it's universally received and standardized all over the world. There are a set of definitive data elements that are associated with a patient, again, as a discrete data concept, and that patient resource, second part of a FHIR definition, is data that can be moved across the web. There will be a URL associated with that patient. That URL could be called between a FHIR client and a FHIR server, and if the access controls permit, that data can be transmitted. So that fundamental definition as we move through this course, having that grounding on a resource is really important. So looking at a resource in a bit more detail here, we're looking at a patient. So within the FHIR spec, a patient profile must include the patient's name, an identifier, which we'll cover in more detail. An identifier could be a medical record number, for example, the patient's gender. These are some of the data elements that must sit within that patient's profile to have that patient considered a full resource by the FHIR standard and definition. Resources, when we look at the fact that all of these elements are built in code, we typically work here in JSON at Microsoft, though XML is certainly supported as well. Resources can be grouped together in something called a resource bundle, a packet of information that could include things such as the encounter. Who was the performer of the encounter? What is the name of the practitioner? What is related to that encounter? Did the patient have a procedure? Outside of this particular example, was there a diagnosis? Was medication prescribed? All of these elements can be associated together in a bundle and that information transmitted as required. There's two ways that we look at bundles. So there's a transaction bundle and there's a batch. So a transaction bundle is something that we'll be supporting in Azure Healthcare APIs. If the system fails to commit a specific resource in a bundle, then none of the resources are committed to the file. So let's say you're trying to pull a large set of data from a health system into FHIR, but one particular resource element, such as encounter, doesn't write to the system in a transaction bundle, then none of the resources will be committed. Where that is true of batch, though there are ways that data can be rolled back and audited to ensure that all of the data that was meaning to be transmitted was done appropriately so. So now we've looked at a resource individually, we've looked at groups of resources, and now we're going to look at another fundamental concept for FHIR, and that's something like extensions. So if we look at the definition of a patient, per the FHIR spec, a patient must have 3 data elements. A patient must support, should an organization want to add other specific data elements, things like the contact of the patient, birthday, address, et cetera, et cetera. But some health systems, some governments, some specific health organizations may choose to support extensions of resources, such as nationality. So if we wanted to run data across our hospital system, we might want to know that Mary is Canadian, or Mary is American, or Mary is some specific nationality for population health purposes. So one of the architectural principles that we'll cover for FHIR is that we really want to have a structure where data is needed for 80% of use cases. So if we look at the left side of the page, most use cases are going to require these types of standardized data sets, but FHIR has the flexibility to enable extensions to be associated with other resources such as nationality. And that's needed for probably 20% of use cases just by specific example. But again, this is a standard that does have flexibility to extend and be customized depending on the implementation at hand. So that's a really exciting part of how FHIR is structured and is able to be used. So we had some base block diagram visuals of FHIR in the prior pages, but now we're looking at an actual screenshot of a resource here, and that resource, if you look on the upper right, is a patient. There are some features to all resources that are standard. We're showing the readable HTML summary here. That's going to contain common metadata, a URL where that resource can be found. What server does this particular patient resource live on? And here we see that the URL is calling a structured definition. What is from US Core specifically, we'll talk about some implementation guides and standards in the coming pages, but what's the URL? Where can we find the definition of this patient? Where can this be found on what servers? And again, all of these data elements are elements that are extensible beyond what's on page here, should we want to add other elements and associate those elements with this specific resource. I talked a moment ago about being able to query and find a URL on a specific resource or resource bundle, and that's the role of a server. So a FHIR server is going to be able to understand a query from applications. It's going to be able to validate that query should this data be released. Is there consent to release and authorize the approval of this data query? Is there specific query or specific data that needs to come back to the FHIR server for any reason? And do we have the ability to actually ship and send resources to the client that's requesting that data? So not only is FHIR as a service something that is a repository and secure hold of data, but a FHIR server really needs to be able to manage securely the egress and ingress of data in and over time. A FHIR client application is going to need the ability to request data in the queried appropriate format, validate that data, organize that data, and of course, make meaning of that data in applications. And that's certainly the role of partners that we'd love to see you continue to build and leverage FHIR, for your FHIR client across our stack using our FHIR server. So we talked previously about 80-20 with the example of extensibility. A big principle in the upper left here is reuse and composability. You want to be able to use FHIR in a way that fits your organization and satisfies your organization's needs. If you are a large customer with health data repositories, again, government-run health institution, you want to be able to ensure that the services that you're using are scalable. So big benefit of FHIR is transactions are stateless, memory use is rather low in contrast to other application types, storage types. Performance, a big part of FHIR. We want to make sure FHIR can be exchanged across networks, and the protocol is designed, again, with HTTP and calling URLs to make FHIR incredibly accessible and usable as a spec. Data fidelity. So FHIR does maintain a hierarchy for lineage. You're able to trace back puts, post to the system. You're able to look at how data moved into the system when it was written in the system and really understand to true up any issues that could happen with data transfers or with patient identities. We've historically talked about an example where I was in the ER actually the other day for a small issue, just a sprain. But if my name was spelled with 2 N's, we would want to make sure that my name and medical record were eventually updated so that I could be appropriately billed, that my history and medical records were accurate, and the system would track the update of associating my incorrect spelling to my correct spelling so that that data fidelity is appropriately managed and preserved over time. And finally, again here, looking at implementable. We want to be able to ensure that applications can connect with these services, make meaning and use of the data, and be able to bring that data to life. So we've talked about resources, we've talked about some examples of resources, and now we'll talk about how these resources are associated in a hierarchy with each other. So at the most fundamental level, resources are going to contain metadata, which we covered. They're going to contain some implicit rules and a specific ID. From that resource fundamental structure, there's a few branches. Resources will either branch off into a bundle, collection of resources, binaries, parameters, or a specific domain resource. So a few examples we gave previously were patient observations, and many of the other canonical resources, normalized resources in the FHIR spec. So these domain resources are going to contain specific text. They're going to be able to point and affiliate and associate with other resource elements when gathered together. They're never specifically exchanged, but they are there to inherit from the base resources themselves. So if we look at that in practice as we move towards some examples, you'll see here when we looked at the hierarchy on the prior page, here's an example of a specific screenshot from the FHIR website where we're showing a specific normalized resource here and showing that that resource must contain an ID describes what an ID is, what are the constraints of that ID, and something that you see on page here that's worth calling out, you see a lot of text that's in blue. This text is in blue because if you're looking to understand FHIR in more detail, when you go to HL7's website, you can click on any of these elements and have a very complete definition of what is an ID, when do I use an ID, what is the cardinality of that ID. Is that resource normalized, or is that resource highly used and adopted, but not normalized globally across all adoptions of the FHIR spec? So again, I go back to really making sure, for those of you who are learning FHIR, getting comfortable with FHIR for the first time, make sure to take advantage of going to hl7.org and exploring the spec from their own words and the community of implementers who continues to develop it. So how do we think about a resource identity, defining that resource, locating that resource? So there's, again, a few branches here. We're going to look at the ID of, or a resource's identity, excuse me, from a few different ways. So location URL, where can I specifically go find that resource? And what are the identifiers of that resource? In the same way that I would have a medical record number, a social security number, that's a way that you could look at an identifier. That's an element that's uniquely ascribed and specific to me, and other definitions like a canonical URL that would support and help define and codify that ID. So we can see here, as we're going deeper into understanding what that looks like pen to paper, this is a patient-specific resource. So you have all the elements that are going to be included in that resource here, or can be, right? Again, FHIR will define, based on an implementation of the FHIR spec, what must be included and what may be included, depending on the implementation. So these are the elements that can be explored further. Again, this is a patient resource, is a domain resource, so that's going to include how do we define what that means. There'll be a very specific definition of what is a patient. There'll be a specific definition of what extensions can be associated and other defining elements associated with that patient. Moving again here to see that in practice, up on the right, you can see that the code is defining the resource type as a patient. The specific ID is scripted out and assigned by the server. That is a big part of the FHIR spec that's important to note here, that the ID can change from server to server. I, as a patient, might have an identity associated on many different servers because I have many practitioners, but the ID for me as a patient is going to be associated with my specific engagement with that hospital group. And that ID can change again from server to server, depending on the full record and identifier of what this specific resource is going to look like. So let's go a bit more into identifiers. They're a resource that has cardinality, which means they can have 0 or many elements. You can see identifier defined by the arrow here in the screen, and the brackets showing that there are very specific sets of data types that are being associated and pulled together with this identifier. And here we're seeing terminology, right? So part of this identifier is going to note what is part of this resource type. My medical record is part of this. What system am I pulling from? What specific code system? That's critical in exchanging health information between different organizations, whether those be payer, provider, or otherwise. And all of this information, again, within an identifier set, can continue to be expanded upon beyond the limited elements that are shown on screen here. So just going deeper into showing some of the canonical URLs that are defined by the FHIR spec. We covered business identifiers in the prior screen. As we look at some of the canonical elements, we can look at things like a questionnaire, a naming system. If I wanted to send a questionnaire to a patient, there's going to be a definitive set of information that's required to send that questionnaire, to capture information in that questionnaire and bring it back. A questionnaire is a very specific term in the FHIR spec. as is a capability statement. What is this specific resource supposed to do? What's the purpose of this resource? That's another canonical URL. Again, these elements are links, so should you want to know more about the specific definitions of some of the canonical URLs shown on screen, feel welcome to go to HL7 and explore that further. So how does FHIR actually get deployed? The FHIR spec can be driven from implementation guides, and those guides are rules that are written by the open source community and those involved in specific deployments to define how to use the resources that are defined across the FHIR standard in deploying those things in practice. Again, we want to think about how the 80-20 rule could be applied, what resources must be included within an implementation, what should be included, where should extensions be used, and within defining an IG, we want to think about constraints. Are there certain elements we don't want to apply? Are there certain customized operations that should be thought about? And each guide contains two types of references. So we're going to have contents. What are the rules for this implementation? How should we move forward with this implementation? And specific use cases demonstrating an example of how the implementation would be deployed in theater. So I mentioned that the US has played a significant role in bringing FHIR to life from a regulatory perspective. Back in 2016, the 21st Century Cures Act was passed in the United States, and some of the main objectives of that act were to ensure that patients were able to access their health information electronically without cost and without friction. It took several years to develop the structures for how the Cures Act could actually be mandated onto health organizations in the United States, particularly those who accept Medicare and Medicaid patients, and defining how how the act would be supported was done by the ONC's final rule and the CMS final rule. So we use FHIR as a part of these rules as the standard for interoperability of health data, meaning that patients are going to be able to access their health data on request, receive their health information electronically within 24 hours, and they're going to do that by having an API connection. Now, again, the patient wouldn't know about the API, but the health systems are going to deploy that behind the scenes for the secure movement of those records to the patient upon request. There are a litany of additional terms moving forward today and in and over time for providers to exchange information across each other, for payers to exchange information across each other, for patients to be able to access a portal where they can see what providers are available to them within their network instead of having to do what we've all done for many years, call a provider, ask if they take your insurance, ask if they take certain coding types. So really reducing the lift and friction for experience on the patient was a big part of this act. Another big part of this act, not to be forgotten and not necessarily stated on screen here, is that innovation and better understanding meaning from large sets of health data was really part of the design and unlocking value from health data by using standards that could be universally adopted. So big kudos to the many, many folks involved in passing and writing the definitions of how the Cures Act would actually be adopted in practice. So this is where we're going to come back to implementation guides. When you saw on the prior page the ONC and CMS's final rulings for what would need to be made real for patients between providers, between payers, an implementation guide was built to say, this is how we're going to move forward with achieving these objectives. The US Core Standard Implementation Guide defines the parameters of implementing for CMS and ONC. It's based on FHIR R4 standards and provides framework for implementation, again, as already stated there. So if you have additional questions, particularly on regulation, we do have a great deck that we can make available to all of you that goes into the FHIR spec and regulation in detail. profiles. So here is a US Core reference. So you're seeing a page particularly from US Core that's going to be part of a main implementation guide showing the minimum constraints required for US Core, the type of profiles used, minimum elements, extensions, terminology definitions. How do we think about a particular hot topic in the States today? How do we think about gender? How do we represent gender in non-binary ways? That those are all elements that needed to be thought about and defined in US Core, both from a structure definition perspective. What are the official FHIR resources we're using? What are the extensions that we want to have considered to go beyond standard terms and canonized resources in FHIR to support the use cases for bringing health data to life in the US? Few more pieces here on US Core. Sets minimum expectations for patient resource. So here I'm looking at profiles specifically, and something that you want to think about within an implementation guide was we said that there's core definitions that are to be moved forward with and certainly constraints, and then the flexibility of what should be supported, but doesn't necessarily have to be defined collectively and together. So here for a patient, there's three things that a patient must have, three definitive definitions, but elements that a patient must support. So this is another way to just think about FHIR's, while it's a very tightly defined, structured framework, the extensibility that FHIR offers to be able to make use of the standard in specific jurisdictions. So now we'll look at FHIR as a RESTful API. So we've talked about what resources are, how resources are defined from a jurisdictional perspective, the role of regulation, but how does FHIR data actually move across a system? So when we think about FHIR as a RESTful API term, data is sent or received from a server to a client on an HTTP request. So the path that the data flows in and some of the key terminology to be aware of that will be used across our hack tomorrow and across the sessions for the rest of the day is how do you write data to a FHIR server? So you would want to post data. So here you see that you can create an instance of a resource. An ID will be generated for that resource. If you want to read data, the terminology for that is a get. You're pulling that data from the system to access, understand it. If you want to update a resource, in the example that I gave previously of a spelling error upon admittance into an ER, you could either do a put or a patch on that data. And we do enable the ability to delete. That's something that we're certainly sensitive to at Microsoft. There are reasons that you would want to delete a resource, but certainly within a core hospital system or a provider system, have some type of ongoing repository where that data is kept in and over time for reasons of health record preservation and otherwise. But you may not need all elements in the exact way that they were initially ingested into FHIR preserved for various reasons. So if we look at an actual string here and a call to a server to get a patient and many records associated with that patient, which is defined here as $patient everything since a specific period of time, you can see how we're moving data from Contoso Hospital and Fabricam's hospital server to call a specific patient record. So again, this is being done with a get here. We're calling a very specific FHIR URL. We have an ID, we have the patient everything call, and this is an example of how you can see here in the lower part of the screen, the patient bundle would be visualized when that data has been called on. Here's a few other examples of RESTful interactions with US Core, so you can see some of the gets and some of the combinations of how you may want to call, particularly a patient. And you could do that through several different ways, a combination of birthday and name using the ID, the patient's name, name and gender. And these are the exact code scripts, that could be written out to make these calls, depending on for example, below here, identifiers such as medical record, you'd be calling a specific hospital system, looking for that record, looking for the patient based on that identifier. So FHIR gives you a tremendous amount of flexibility to look for something that you could see here as definitive, patient is a capital P, but do that in many ways with the data sets that must be or may be associated with that patient. So we're going to move here to transition to a break. We're a few minutes before our split point, but want to give everybody a few minutes before we transition to Todd's presentation. We will be watching and answering questions in the chat. Thank you for kicking off with us and getting through the opening description and definition of what FHIR is so that you're very well grounded in how we can think about the value of FHIR in the Microsoft ecosystem, its value for connecting data interoperably between health organizations and applications with FHIR server in the middle. And when we come back from break, we're going to dive right into more detail on our broader reference architecture here at Microsoft and putting together some use cases. So thanks for being with us for this opening hour. We will reconvene at the top of the hour in 20 minutes and go from there. So thanks again, everybody. We'll see you in a few minutes. Appreciate your time in joining us today.